that measure of angle K has to be smaller than the measure of angle L. All right, so for our first step, we're going to assume the opposite. So step number 1, when we look back at our notes, step number 1 says to identify our conclusion, which is the proof part, and we're going to state the opposite is true. So in this one, we have it's less than. So what other options are there for two numbers other than for one number to be less than the other? Greater than, so measure of angle K is greater than the measure of angle L. Shook her off your phone, dude. Shook her. All right, and then other than greater than, two numbers could be less than, greater than, or what's our last option? Equal to. And I'm going to kind of draw this line down that or because we have two cases. There's two things that could happen. Rather than measure of angle K being less than measure of angle L, we could have greater than or equal to. We're going to show that these are the only three options. If this one doesn't work and this one doesn't work, the only one that can work is this one. Okay, so we're going through all the options. We're going to prove that these don't work, which means that this is the only thing left, so that has to work. Okay, so step number 2. We're now going to use logical reasoning to show why this wouldn't work. All right, remember when we have angles in an order, angle K is greater than angle L. Back to Monday. We know that the longer side is opposite of the biggest angle, right? So if I know that angle, and that's our angle side relationship theorem, so let's write that down for step number 2. What side is opposite of angle K? J to what? Remember, we're looking for a side. JL. Good. So if I have K, JL is opposite. So JL would have to be bigger than, what's the measure of angle L? Or what's opposite of angle L? KJ. Good. Remember, when we look opposite, we're looking across. So across from angle L would be JK, or KJ. And how much is JL? 7. So we're going to say 7 is greater than, what's JK? 8. JK is 8. Is, in the real world, 7 greater than 8? No. So does this work? No. So that's our contradiction. This does not work. I'm going to lightly cross it out so I can still see it, but I know this is our contradiction. That doesn't work. So if angle K was bigger than angle L, then that side would have to be bigger than this side. And are they the bigger? Nope. So this does not work because 7 is not bigger than 8. All right, this one we kind of have to jump back to trimester 1 just for a moment. This one we're saying measure of angle K is equal to measure of angle L. Does anyone remember what we call a triangle where two angles are equal? Going back to chapter 4, which type of triangle has two angles that are equal? Yeah, isosceles. Beautiful. So isosceles, we have two angles that are congruent. And remember, what is also the same about two congruent angles then? How many sides are the same? Two. Two sides are the same. This is our isosceles triangle theorem that if we have two congruent angles, the sides opposite of them are also congruent. Okay, so that's our isosceles triangle theorem. So for step number 2 here, now we're working on the second case. If they were equal, our isosceles triangle theorem. If we had two congruent angles, then we'd have to have two congruent sides. So what side is opposite of angle K? JL. And what's the side that's opposite of angle L? KJ, or JK. So if those angles were equal, then we'd be able to say, yep, now those sides are equal. But are the sides equal? Is JL equal to KJ? No. Is it an isosceles triangle? No, it's scalene. So how much is JL? 7 would have to equal, what's KJ? 8. And in this reality that we are currently living in, is 7 the same as 8? No. If you tell a 7-year-old or an 8-year-old, you're pretty much like a 7-year-old. Are 8-year-olds going to like that? No. Even 8th graders, if you tell 8th graders, like, you're like a 7th grader, are 8th graders going to like that? No. They're like, 8 is not the same as 7. All right, so step number 3, last step in this one. We have to explain why this doesn't work, or we have to come up with our conclusion. So we showed why it doesn't work. Now we just need to state, okay, this didn't work and this didn't work. So our only other option is that angle K has to be less than angle L. So because neither option above works, so these two options didn't work. There was only 3 options to be had. So if 2 options don't work, the only thing that's left is that third option, which is what we were trying to prove in the first place. So because neither option above works, we know measure of angle K is less than the measure of angle L. It wasn't greater than, it wasn't equal to, so it must be less than. All right, we're going to do one more example. This one is hopefully going to make a little bit more, maybe a little bit more sense. Maybe you can kind of piece together these parts. It's still new, so it's okay if we're not feeling super confident in this yet. Like I said, we did proof by contradictions in college all the time. Every time I said do this by contradiction, my brain was like, please no. Okay, I get it. This one's tough. It's kind of weird to do an indirect proof, go not the right way through it. All right. Yeah. Alright, here we go with the last one. Last example, and then again we have a really short practice today. So, a triangle can have at most one obtuse angle. A triangle can have at most one obtuse angle. So if you were zoned out, you were on your phone, you were taking a nap, this is a good time to zone back in. It's our last example. Alright, so what are we trying to prove? What's our overall statement? Triangles can have at most one obtuse angle, right? Is it saying every triangle has to have an obtuse angle? No, that word at most means it can only have one or none. Not more than. At most means no more than. So for step number one, if I assume the opposite of that, we're going to say assume. What would be the opposite of a triangle having no more than one obtuse angle? What would be our other option than a triangle can have at most one obtuse angle? Can have more than one. Good. Assume a triangle can have more than one. More than one obtuse angle. So that's our assumption, and we're going to show, okay, now we're living in a world where this works. A triangle can have more than one obtuse angle. So let's draw a triangle. Just any triangle. Doesn't have to be accurate. We're just going to use it as reference, so that way when we're thinking about our math, we can kind of piece together where it is. So let's just label our angles. Let's do 1, 2, and 3. So we need to have more than one obtuse angle. So which one of those angles do you want to be obtuse? I know they don't look obtuse, but that's okay. You want 1, 2, or 3 to be obtuse? 1 and 3? Okay. So what does obtuse mean again? Good, more than 90. So we know that the measure of angle 1 is more than 90 degrees, and the measure of angle 3 is more than 90 degrees. Okay. Rama, Yusra, Rama, focus. Okay, so we're saying that we have two angles that are more than 90 degrees. But what do I know about all three angles in a triangle? All triangles, when you take the three angles, what do they add up to? 180. Okay. So if I add these three angles, measure of angle 1 plus measure of angle 3, Let's just add those two together to start off with. If angle 1 is bigger than 90 and angle 3 is bigger than 90, yeah, this is going to be more than 180 degrees. So now if I add all three together, I'm adding in an extra number. Is there any way that all three of those added together would equal 180 if two of them already was bigger than 180? No. So that would not equal 180 degrees. And that's something that we know as a fact in our world, that when I add three angles of a triangle, it has to make 180. It doesn't matter what the second angle is, whatever it is, when I add them together, it's going to be not equal to 180, because when I add two of them, it's already bigger. All right, so for number 3, we're going to now state that kind of in a summary. The triangle angle sum theorem says three angles must equal what? What do the three angles in a triangle have to equal? 180. And we just showed, is it going to equal 180? No, so we're pointing out the contradiction. We're saying this is why it's wrong. They have to equal 180, and this doesn't equal 180. So by contradiction, we can use therefore, in summary, finally. Usually by these proofs, we like to say by contradiction or indirectly. So it doesn't work for a triangle to have more than one obtuse angle. So what's our only option then? What does a triangle have to have? What were we trying to prove? A triangle can, what was the problem? Can have at most how many obtuse angles? 1. Okay, so again, indirect proofs, I know it's a little bit harder because we're now, instead of just proving it using the theorems and the stuff we know, we're going kind of the roundabout way, which feels silly.